Hi, Hickory Creek 7th graders. For those of you who do not know me, I am Mrs. Dahan, and I teach math on Team 7A. So today's lesson is going to be as brief as I can possibly make it. This is actually take two. My first video didn't work for some reason, and it was way too long. My students will tell you how that happens all the time. So anyway, we're going to talk about angle and line relationships. So we're going to start out with adjacent angles, vertical angles, and then from there, move into complementary and supplementary angles. So let me first share a screen with you. Okay, so this is the first picture. Let me make it a little bit bigger. Okay, this is the first thing I'd like to talk to you about. Again, I'm going to try to make this a little bit brief. So if you find that I'm going too fast, just rewind it, pause it, write things down, and I'll try to be as concise as possible, which is not easy for me. Adjacent. The word adjacent means next to. So adjacent angles are two angles that are next to each other. So the two angles that are adjacent in this first illustration I'm going to highlight here would be angle BAC and angle CAD. Notice when I named those angles, the middle letter always has to represent the vertex. Okay, so the yellow angle there can be CAB or BAC because A is always in the middle. And same with the green angle, it could be CAD or DAC. All right, so I'm going to get rid of those lines real quick and talk about the equation that they're asking us. It says here statement, write a mathematical or a mathematical statement that describes adjacent angles. Well, in this picture, angle BAC is represented right here, as you can see where my cursor is, as angle A. Angle CAD is represented with angle B. So sometimes we name angles by the capital letters that are points on the lines and the vertex, and other times we have either a lowercase letter or other times it might be a number, and we can call it by it's labeled in its interior. So the statement we're going to write here, let's put this in red so it shows up a little bit better. The statement that shows adjacent angles would be A plus B equals C. Okay, so I did that with the mouse for some reason and not my stylus, but it turned out okay. The one notation I'd like to show you is the symbol like that, and I'll put that in the abbreviations. That simply means angle. So if I was talking about angle BAC, I would write angle BAC. Okay, and sometimes you might see a little M in front of that. That simply means the measure of angle BAC. M meaning the measure, like how many degrees. Okay, so that is all that we need to worry about in terms of adjacent. In summary, the characteristics of adjacent angles is specifically that they share a common vertex. In this case, it would be vertex A. A is the vertex for each one of those angles. And adjacent angles also share a common side. So this ray right here, AC that I highlighted, that's the common side. So adjacent angles are next to, they share a vertex, and they share a common side. Okay, vertical angles. Vertical angles, change my color here. Vertical angles simply are angles created when two lines intersect, and I like to think of it as they form an X. And vertical angles are the angles that are across from each other. So in this illustration, angle A is vertical to angle B. Now, this notation here that you see Let me highlight it. This notation here, as well as over here, that little arch that's on the inside of the angle, that represents congruent or congruency. So that means that they're the same. I'm going to erase those for right now. Okay, so the statement we're able to write in this problem would simply be the measure of angle A equals B, because vertical angles are congruent. Now, the symbol for congruent, in case you may not have seen this, is a squiggly line with an equal sign underneath. So I could say, if I wanted to write this in a geometric fashion, instead of calling this angle A, I could say angle DCF is congruent to angle GCE. Okay, so that is all there is to know about vertical angles. And again, the characteristics are just like adjacent angles. They share a vertex. In this case, they share vertex C. But what's different in vertical angles compared to adjacent is that there are no common sides. So you can see very clearly that the angle marked with A has the sides DC and CF, and the other angle marked with the B has sides of GC and CE. Okay? All right, so now let's move on to the next term or terms. Now, some of these, let me make this a little smaller. There we go. All right, so some of these concepts might sound familiar. They were on the bell ringers that we were doing right before we took a break from school. So some of this is new, some of it, it might just be a refresher for some of you. Others, you might need a little bit more to take down a little bit more notes. All right, so we have complementary and supplementary angles. So I'm not going to write the definition here because it would be painstakingly long for me to use the stylus and write out definitions. I'll just be very quick. Let's make our life a little bit easier. And this 30-degree angle, I'll show you with the cursor that I'm talking about, this one here. Let's mark that angle 1. And the 60-degree angle here, we're going to name 2. Okay, that way I can call it angle 1, angle 2, since there are no variables or points, not variables, points on this diagram. So very simply, the measure of angle 1 plus the measure of angle 2 equals 90 degrees. That's the statement we're going to write down, because the definition of complementary angles are two angles that have a sum of 90 degrees. So you may also notice, how do I know that's 90 degrees? Well, this right here, see that little square in the corner of the angle? That is the notation for right angle. So anytime you see that square in the corner, you know for sure that that's a 90-degree angle. You can never assume that it's 90 degrees just because. Pop-up time. Okay, so what you will always see when you have that, you'll know that it is complementary because it's a 90-degree angle, and two angles that have a sum of 90 is the definition for complementary. Okay, sorry, I got a little distracted with all the pop-ups. All right, so this diagram has two different sets of complementary angles. You'll notice the first set that I did the markings on, those are also adjacent. So complementary angles can be attached, meaning adjacent angles. They share a vertex, they share a common side, but they don't have to be. So the same two angles, and I know they're the same because it was a 30-degree angle and a 60-degree, can be two separate angles. We can still say that they're complementary, okay? Just because they're not attached doesn't mean it doesn't work. Still works the same way. So if I named these bottom two angles here, angle 3 and angle 4, I could also say the measure of angle 3 plus the measure of angle 4 also equals 90, okay? Now, on the same page as the, complementary, talking about adding up two angles. Supplementary angles are very similar in the sense that when you take two angles and you add them, in this case, if it equals 180 degrees, they are called supplementary. So just like we did in the last one, let's give this angle, we'll call this, oh, I don't want it to be yellow. We'll make it another color. Let's make it purple. Okay, so if I name this one 1 and this one 2, I can say that the measure of angle 1 plus angle 2, the measure of angle 2, I guess I don't need the M there, I put it there, equals 180. Okay, and just like in the first example, they can be adjacent, like in this first diagram, they're attached, so they're adjacent angles, but they don't have to be. So down below here, you see we have the same two angles, except they're separated, so they do not share a vertex, but it's 120 degrees for this angle, 60 degrees for this one. So because they equal or have a sum of 180, we would still call them supplementary. So a quick little way that I remember, because sometimes students have a hard time remembering which one is the 90-degree pair and which one is the 180. I like to think of complementary. I focus here and I think, oh, well, complementary, it begins with the letter C. So complementary angles begin with C. The other word that I like to think of that starts with C is corner, right? And we know that 90-degree angles make a perfect corner, like you would have a corner of a square or the corner of a rectangle. I like to think, oh, corners are 90 degrees. The corner of a piece of paper, 90 degrees. So complementary, I think, starts with the letter C, so does the word corner. Just a little trick that I like to use to remember which one is which. If I do the same with supplementary, I think, what's a word that starts with S? Well, S starts the word supplementary, but it also starts the word straight, as in straight line. Oh, it's getting a little sloppy here. Okay, so supplementary angles make a straight line, which we know is 180 degrees, and complementary angles make that perfect corner, which we know is 90. Okay,